Okay, so talking about decarboxylation. Decarboxylation stands for losing a whole CO2 group, CO2 from our molecule. So basically, we're gonna lose this whole COOH group later when we're making our final product. Okay. So how does it happen? First of all, we need to have 2 carbonyl groups, one in the beta position compared to others. So this is the alpha. If I'm looking from here, alpha, beta position. So they need to be in the beta position from each other. So here we have a lot of breaking and making bonds. So first of all, here we make this bond and break this one. And this one here, we make another bond, break this one, and make this one. So this is the intermediate state where we have breaking and making bonds. It's a slow step. We ended up forming what we call the enol, the keto form, and the enol. And if you remember from chapter 8 to 9, we talk about tautomerization. So what happens here when we got at this point is the tautomerization, and our final product is losing this whole CO2 group, meaning I'm going to lose the whole carboxylic side of my molecule associated with the oxygens, except this hydrogen. This hydrogen I'm going to lose later on in the tautomerization process. But basically, we can make on here my example, because we have 2 carboxylic acid functional groups, we ended up losing one. On here I have a ketone, and also have a carboxylic acid, and we ended up forming just a ketone. So the intermediate step for both of the processes are the same, breaking and making bonds. And depending on your professor, and he can require you to know this or not, just depending on your professor, so ask him or her about it. This is one thing that we learned earlier in 351, the enol formation. So it would be good to go back and review tautomerization at this point here, and then in a fast step we get our desired carboxylic acid. And this is it about the decarboxylation reaction.